Question number 56. Mark the incorrect statement among the following. So the first statement, it says metal excess defect due to an anionic vacancy can lead to the crystal showing color. So this is correct. This is seen in the case of KCl, NaCl, etc. If we talk about the second statement, impurity defect may cause both increase or decrease in the density of an ionic solid. This is also correct, students. It depends upon the ionic solid and the type of the impurity present. So the impurity may either increase or decrease the density of the ionic solid. If we talk about the third statement, ionic solids generally maintain electrical neutrality for different types of defect shown by them. This is also correct, students. And if we talk about the fourth one, metals have a large difference in energy between their valence band and conduction band. So this is incorrect, students. For metals, the difference in energy between the valence band and conduction band is not that large. Okay. So the fourth statement is incorrect and we have to mark it as the answer to our question. Let us look at the next question now. Question number 57. A metal atom having a radius equal to r angstrom crystallizes in a body-centered cubic unit cell. Another atom is present at one of the edge centers in the lattice without distorting the lattice. The radius of this atom is found to be x angstrom. Then the value of x is. Students, it is given to us that the metal atom forms a BCC unit cell and another atom is present at the edge center without distorting the lattice. So we can first use the equation of contact along the body diagonal. So if the edge length is assumed to be a, then the length of the body diagonal is going to be equal to root 3a, and root 3a will be occupied by 4r. Okay. Now if we try and figure out the radius of the atom which is present at the edge center. So we can have an edge. So at the corners of the edge, there are two atoms having radius equal to capital R, and it is given to us that at the edge center one atom is present without distorting the lattice. So the diagram is not drawn according to scale, students. Please don't get any idea out of the diagram. It is not to scale. So we can figure out the radius of this green sphere which we have drawn here. So this length from the center of the blue atom to the center of another blue atom is equal to a. Okay. And if we talk about the dia of this green sphere, we're going to have the diameter equal to a minus 2r. Okay. So we are interested in the value of the r, which is d by 2. So we can have r is equal to 1 by 2 times a minus 2r. All that is left now is to substitute the value of a in terms of r, as the examiner seems to be interested in the radius in terms of capital R. So we can have a is equal to 4r by root 3. We can put the value of a. So we have r is equal to half times 4r upon root 3 minus 2r. So this on simplification will give us a value equal to 2r by root 3 minus r. So this is equal to 2 minus root 3 upon root 3 into capital R. So if we look at the options which are given to us, we can clearly see that the correct answer to this question is given in option 2. Let us look at the next question now. Question number 58. Consider the given statements about the ionic solids of type AB and AB2 that crystallize in cubic closed packed structure. So statement 1, it says in the AB type structure, the coordination number of both cation and anion can be equal to 6. So this is correct for the NaCl type structure, students. The Cl minus forms the lattice, whereas Na plus is present in all the octahedral voids. So the coordination number of Na plus is 6. If we talk about the Cl minus at the corner, it is also in contact with the Na plus present at the edge centers. So there are 6 of them. So the coordination number of both cation and anion are equal to 6. If we talk about the second one now, in the AB type structure, the coordination number of both cation and anion can be equal to 4. So this is correct for the ZnS type structure, students. In the zinc sulfide type structure, the zinc ions are present in tetrahedral voids. So coordination number equal to 4. If we talk about the sulfide ions, so the sulfide ions form the FCC, in which the zinc ions occupy alternate tetrahedral voids. So there are 8 tetrahedral voids surrounding a sulfide ion at the corner, and out of those 8 tetrahedral voids, only 4 of them are occupied. So coordination number of sulfide ions is also equal to 4. If you talk about the third statement now, In AB2 type structure, the coordination number of A2 plus is half times the coordination number of B minus. So this is incorrect, students. For every A2 plus, there are 2 B minus in contact with them. So the coordination number of A2 plus has to be twice the coordination number of B minus and not half as mentioned to us in the question. So the third statement is incorrect. So for this question, we have to mark the statements which are correct and we have to select the first option as the correct answer to question number 58. Let us look at the next question now. Question number 59. Which of the following statements is incorrect regarding the hexagonal close packing in 3 dimensions? So if we talk about the options which are given to us, half of the octahedral voids and half of the tetrahedral voids are shared between 2 unit cells. This is incorrect, students. The octahedral voids are not shared at all in the hexagonal close packing in 3 dimensions. So the first statement is incorrect. If you look at the second option now, there are 6 octahedral voids inside the unit cell which are not shared between 2 unit cells. This is correct. If you look at the third statement, 1 unit cell has 6 octahedral voids and 12 tetrahedral voids. This is also correct, students. In a close packed structure, if there are n atoms forming the lattice, then there will be n octahedral voids and then there will be 2n tetrahedral voids. Okay. So the third statement is correct and so is the fourth statement, which says that the effective number of atoms in a HCP unit cell is equal to 6. So for this question, we have to select the incorrect statement and the answer to this question has to be marked as option 1. Let us look at the next question now. Question number 60. Which of the given statements is correct? Option 1, it says paramagnetic substances show their magnetism even in absence of magnetic field. This is incorrect, students. The paramagnetic substances are magnetized in the presence of magnetic field, and as soon as the magnetic field is removed, the paramagnetic substances, they lose their magnetism. So the first statement is incorrect. If you look at the second statement now, diamagnetic substances are weakly repelled by a magnetic field. This is correct, students. If you talk about the third statement, ferrimagnetic substances have all domains aligned parallel to each other in presence of magnetic field. This is incorrect. This is not for ferrimagnetic. This is for ferromagnetic. Okay. If you talk about the fourth statement now, antiferromagnetic substances have domains oriented oppositely in unequal number. So this is incorrect, students. Antiferromagnetic substances have domains oriented oppositely in equal numbers. The explanation given in statement 4 is regarding the ferrimagnetic. So in the ferrimagnetic substances, the domains are oriented oppositely in equal numbers. So the third statement as well as the fourth statement is incorrect. So for this question, we have to select the correct option as option 2. So this is it for today, guys. I hope the solutions were clear to you. Thank you.